Okay. So for the class today, I have shared one data set, which is a zip file. Can you access the data? So have you found the data? I have given you a data set in the WhatsApp group. Can you have access to the data? Can you open it? So we will be working with this data today. Okay. So first of all, let us open this new project and add the data that I have given you. So this data is again from Manipur, and then it is where we have stopped in the last class. So how will you add data? We go to layer, add layer. If it is a vector layer, then we will add vector data layer. Okay. So I redirect to the data set. So this is the folder, exercise of geoprocessing data for Manipur. Okay, and this was the data that I shared in the zip file. So you have to save this zip file and then unzip this folder somewhere in your local drive. Okay, so there, as you see, we have basically three different kinds of data. So one is this shape file. This is the Manipur shape file, and then we have the stadium. This is the stadium, and then we have the assembly building. So I open all these three data set like this, and I then add it like this. Okay, so I ask all of you, please add the data. Okay, so this is where we stopped in the last class, is it? This is Manipur. So in order to show the different districts, I go to the symbology, then I go to categorized, then in the value field, I select the name to, then classify it, and then apply. So we have this different data. In the assembly building as well, I will change this size a little bit bigger, 5, apply, okay. And then this one also, I will increase the size to 5. Okay, in order to label this, how would I do it? Go to property, then go to label, then single label, and then in the value field I put the name. So this is the assembly building. And then again for the stadium, I go to label, then single label, in the value field again I choose the name. Okay, so this is for the time being. Okay, so can you see this on the screen? And are you also using your data set? Hello? Can you hear me? Hello? Yes or no? Somebody has to speak, otherwise you will be losing your time.
I can hear you.
Yeah. Next. So today, as I said, I will show you a few of the geoprocessing tools. So geoprocessing tools you can find in vector geoprocessing tool like this. So what are the geoprocessing tools that we have? We have one tool which is known as the buffer, another one is clip, another one is convex hull, difference, dissolve, intersection, difference, union, and then eliminate selected polygons. So all of these tools you have to use whenever you will be using some GIS project later on. May not be all are at the same time you will be using all of them equally, but few of them quite frequently you have to use these tools. Okay, so there are 2-3 different ways how you can access these tools. One is with the inherent uh, processing tools which comes with the QGIS, that is the one that I am showing on the screen right now. You have to go to the main menu, vector, geoprocessing tools, and then you can go to buffer, or you can go to the right side, this processing toolbox. Do you see this processing toolbox? Then you can type the name of the tool that you want to use. For example, if I want to use the buffer tool, I will simply type it BUFFER. So as you see, there are different ways how I can access the same tool. So some of them can be accessed by the ZDAL function that comes with the QGIS, where you can say buffer vectors, one-sided buffer, or you can use the GRASS GIS function, which is sometimes it is inbuilt in QGIS, few of the functions. You can use r.buffer. Then you can also use the Saga tool in order to buffer. So many of these tools essentially they can give you the same function. So we will see today how we can use buffer. So what is buffer, first of all? So in order to know what is buffer, I will simply give you an example here. Let me use that, what is it known as the, what was it called? Paint box, paint app. Okay, so dear, I think you'll have to share this again. Just one moment. Okay, so for the timing I'll stop sharing of this thing, and then I am sharing this paint whiteboard. Okay, so what is buffer? Here, B-U-F-F-E-R, buffer. So buffer, for example, you have some data. It may be a point data. For example, on the screen I write P. This is a point data, and unlike or like any other GIS data, it will have its own location. That means it will have its lat and long in terms of x and y. Okay, it can be latitude and longitudes in terms of x and y. So buffer means if I use this function, then around this point, or from this origin or from this location, what is this distance that I want to buffer? For example, if it is a point and I choose my buffer distance to be, suppose, 1 kilometer, then on the screen it will select a circle with a radius of 1 kilometer. Okay, so anything that will come inside this circle, there may be houses, there may be trees, there may be lakes, or anything, it will be included. And in the same time, if it is a linear feature, if this is a road, and I want to use the buffer function for, suppose, 500 meter, okay, 500 meter. So it will mean that from both directions or both sides of the road, I can select whatever objects you have with a distance of 500 meters from that linear feature. Okay, so if it is a polygon or if it is a lake, something like this, and I use the buffer function of suppose 20 meter. So anything that is with buffering distance of 20 meter, it will be selected on either way. It can be on this way or it can be towards the center or the centroid of this polygon. So this is essentially the buffer function. It is very useful function. You have to often use it many a times whenever you will be doing your projects. Okay, so let us stop sharing this thing and then directly go to the function itself. Okay. So do you see the screen now? On the screen, is it visible? Yes or no?
Yes, sir.
Yeah. Okay. So remember, in one of our earlier classes, we were talking about the CRS, or the Coordinate Reference System. So what is a CRS? CRS is the projection system that is inherent of the features which are being used. For example, there are three features as you can see in the project now. One is the assembly building, another one is the stadium, and another one is the state of Manipur. So if I go and click on the property and then I go to the information there, it says CRS is EPSG 4326 WGS 1984. So this is a three-dimensional coordinate reference system. So if it is a three-dimensional coordinate reference system, the default unit is in degrees, as you can see here. So you talk in terms of degrees, either 1 degree or half a degree or 0.25 degree, something like that. So 1 degree, if you travel along the equator, it is almost 111 kilometer. So 1 degree represents about 111 kilometers along the equator. But if you're traveling towards some of the latitudes of the equator, then these values might change a little bit. So you have either unit in degrees if you are using a three-dimensional coordinate reference system. But in order to specify a distance, for example, a buffer distance of 200 meter, there may be, you can either convert these degrees into meter, or you can simply change the projection of these shapefiles into a two-dimensional CRS. So in order to know, or in order to change the work between the projections, you need to know what is the UTM of the area, or Universe Transverse Mercator Zone. Okay, so for Northeast India or for Manipur, as you are working in this area, it is 46 north. Okay, so first let us change the projection, because all this data set, they are in a three-dimensional coordinate reference system and the unit is in degrees, as you see. Again, you see for Manipur it's also in degrees. So let us change the projection. So do you remember how we changed the projection? We went to vector, data management tools, then reproject layer. Okay, are you with me, everybody? Hello?
Yes, sir.
Okay, good. So I pick up reproject layer. See? Now, you can do it going to the input layer, clicking up the layers here, and then the target coordinate reference system, or you can use it as a batch process. So what is a batch? As you see, run as a batch process. So batch means you can do it, or you can automate it more. If you have more than one files, the computer will be doing the same process repeatedly. So since you have three of these shape files, and then you have to do it 3 times rather than doing the same thing 3 times, you can go to run as a batch process or click it here. Okay, so once you click there, you see that we have we have we have one drop down menu where we can pick up the input layer. So in the input layer, these three layers come up, and then you can add other layers here, add row. So I add 3 rows because I have 3 layers. So first layer I pick up Manipur, then you say the target CRS. So the target CRS, this one is the 3-dimensional CRS. I don't need it. I need a 2D CRS with UTM zone 46 naught. If you do not see this thing here, you can go there and then type UTM 46 naught and then WGS 1984. So you pick this one and then click from there. So once I have used this thing, so it is already saved, I can directly pick up that. So similarly for the other 2 layers, okay, then I go to the folder where I want to save these reprojected files. So there I go into the same folder of my processing data Manipur layer. I create a new folder and then I write as reproject. Okay, and then I go inside that and then I change the save as shapefile. So my first layer is the Manipur shapefile. So I say my reprojected layer is MANIPUR 46 naught. Okay. So remember this file type should be .shp. Then I save it. I click OK. Do not autofill. Then I go to the second layer. My next layer is the assembly building layer. I click there. I again go to the target CRS as the 46 naught, and then in the file where I want to save it, I go to the same location and I click it, assembly building 46 naught. I write it in the short form. I save it. And again, my third layer is the stadium. I go to the same process. I go there. I pick up the shape file and I say stadium 46 naught. I save it. Okay, everybody. Now you see. Then you click load layers on completion. So once this process will be finished, it will automatically be loaded into the software. So then I click run. It is done, closed. So these were now 6 layers. The last one, Manipur, this one. My reprojected layers are this one, these 3. Okay. These are my reprojected layers. See. So wherever 46 naught is written, that means I have renamed this and it is the reprojected layer. So for example, this AB46 naught, I go and check the property now. Wait a minute. Yes, so you see the unit is changed to meter and then the coordinate reference system is WGS. It should have been actually 1972, not 1972, but 1984. But anyway, for the time being, it doesn't matter. 46 naught projected. Again, stadium, same thing, 46 naught projected, and then unit is in meters. And then Manipur also. Now, all my layers are now projected into a 2D coordinate reference system. Okay. So, what next? Now, I want you to do a geoprocessing work. Here. Again, I go there and then I go to the label. I label my layers. Again, name it. Apply. Okay. This is assembly building. Then again for the stadium, I go there cancel, and go to label, single label, and then I say name, apply OK. So this is the stadium, and then this is the assembly building. So these two locations, remember, we took from Google Earth, and now everything is uh, in a two-dimensional coordinate reference system. So if you click here on the scale measure, you can find the distance roughly from here up to here in a direct way. So as it goes in terms of kilometers, as you can see, it says the distance from the stadium to the assembly building, if we go directly, it is about 1.24 kilometers, or 1.2 kilometers to be roughly saying. Okay? Yes. Now, are you with me up till now? Everyone? Hello? I don't hear anything. Are you there?
Yes, sir.
Yes, sir.
Yeah, good. Because you please, even if you cannot do together with me, you please concentrate on the video that I am showing, because these things you don't get to see quite often, okay? And these are minute things you need to know once you want to operate the GIS. Any software, maybe in QGIS or in ArcGIS or in GRASS or Saga, wherever. Okay. So now my question, I want to know, for example, uh, what are the areas, or what is the coverage about a distance of 1 kilometer from the center of the assembly building? Okay, so that is the purpose. I can use the buffering tool. As I say, you can go directly to vector geoprocessing tools and then buffer, or I can go to the toolbox and I type buffer, B-U-F-F-E-R, buffer. So in the GDAL function here, you have the buffer vector, or you can use the GrassGIS function r.buffer. For the time being, I'll show you this one, buffer vector. Okay, I double click, I have a window like this. Then remember, in the input file here, you have to pick up the input file which is already projected. Yes. So my assembly building projected file name is ab underscore 46 node. So this is the one. Okay. And I mention the buffer distance. On the right side, I choose kilometer. How many kilometer I want to buffer? I want to buffer, for example, say 1 kilometer from the assembly building. So that means from here, I will see how much is 1 kilometer. And then when I go down, I can save this to the temporary file, or it can be saved in temporary folder. And as I said again, you can run this thing in the batch. So let us try running this thing in the batch file. I go there, as you see, I add one more row. So here I want to know the buffer distance from the stadium also. So the buffer distance from the stadium, this is my input file, stadium underscore 46 naught. And then my buffer distance is wait a minute, buffer distance is, just a moment, I don't have an option to give either it is in meter. Wait a minute, no need. So for the time being, uh, I don't use the batch process. Just one by one, let us do the buffering. Okay. So first of all, the stadium. Let us buffer it 1 kilometer across the stadium, and then uh, I use open file after running the algorithm. Run it. Okay. So this is the result. Do you see it? This is the buffer of 1 kilometer across the stadium. So that means this is a circle, and then this is the center of the circle, and then from here to here I have now 1 kilometer. You see, it's almost 1 kilometer, but exactly it is 1 kilometer. Similarly, I want to do a buffer analysis across this assembly. So again, I go to buffer vector, and then in the input file I click assembly building, which is projected, and then in kilometer, and then 1 kilometer exactly. So run it. Okay, so these two are the files, is it? See, so this is Manipur, this is Impal, this is the stadium, and this is the assembly building. And then we have 1 kilometer buffer of these two shape files, so point shape files. Now, after buffer, what is the actual purpose of doing this buffering? So I want to see how many restaurants, suppose, are there. Okay, so if I go back again to my Google Art, let me share this thing. Stop sharing. I share my Google Art, and I type Impal, Phal, Manipur, search it. Okay, already we took these two reference points from Google Earth. That is why it is already there. This is the stadium, and this is the assembly building. So suppose someone is going to Manipur, and then someone is going who is quite new to the area. So he wants to stay the night in a good hotel. So, and then he wants the hotel to be in such a way that it is 1 kilometer surrounding the stadium. So that is the purpose that you do this buffering analysis. Okay, so you will have all the hotels which are inside the stadium with a radius of 1 kilometer, and then your criteria accordingly within 1 kilometer, the computer or the software will deliver you the hotels which you want to stay for the night, because your work is in the stadium there itself. So first of all, can you tell me, are there hotels around 1 kilometer in across the stadium, centering the stadium in Manipur? Those from Manipur may be able to say. Do you have hotels there? Hello? Hey. Those from...
Yes, sir.
You from Manipur?
No, sir.
Who, who is from Manipur? Anybody who knows this place?
Yes, sir.
So we are looking for some hotels which should be 1 kilometer across or surrounding the stadium. Okay, so even if you know the place, you want to communicate with someone else. So that is precisely the reason that you want to make this analysis or do this analysis. So first of all, let us assume that there are some hotels which are 1 kilometer within the radius of the stadium. Okay, and then you know the places, and then you have already plotted those things in your GIS. Okay, so this is a hypothetical data, and that is why we are creating these hotels around the stadium. So how can we represent the hotels? We can represent the hotels by two ways. It can be a point feature, or it can be the polygon or the built up area of the hotels. Okay, so let us create these hotels. If this is it a hotel? No. Or maybe it may not be a hotel, but suppose we are looking for some of the important buildings. So for that, I am going to create these important buildings which are near the stadium. So for that, I go there, add image, where is it? Add polygon. So this is how you create in Google Earth, okay? Because we don't have data, we are creating the data. So you say building 1, BULD01, and then this is one big building. Okay, I don't know what this building is. Then I create this building. Okay, this is building 1. Then another important building, maybe as I see in Manipur. Okay, this is another important building. I go and create BULD02. This is one other important building. Okay, then we have one more building. I'm picking up the big buildings which can be seen from satellite image. BULD03, maybe this one. Another one. This one. 04. Okay, one more. Suppose there is a building here. Zero 05, and then one more building. I pick up one more building. Wait a minute. Probably here. Okay, so these are a few KMZ files which are representing the various buildings in and around that what to say. Okay, so I have to again save these spaces. As a KMZ file. Building 1, building 2, building 3, building 4, building 5, building 6. Okay, now I stop sharing this one and I then go to share my GIS here. So how can we add these things? I go to vector layer, layer, add vector layer. I go to to the same folder, in the KMZ file. I have all these buildings up till here. I click open and close. Okay, so here you see, do you see the buildings now? Do you see it? Hello? Hey, why don't you speak? Okay, so these files you have to save the individual buildings in one shapefile in GIS. So these are various different buildings, as you see, around the stadium. Okay. Hello, can you hear me? Are you there?
Yes, sir.
Oh, okay. So now, actually, why we are doing it here? We want to do a query, and then we want to know how many buildings are there, suppose within 1 kilometer radius, or how many big buildings are there within 1 kilometer radius of the stadium. So that is why I want to find it. If it is 6 buildings, it is easy for you. If it is not a very complex analysis, but I am showing you the method right now. So first of all, we have to create one shapefile of all these buildings. For the time being, these are now KMZ files, you see. So for our analysis, we have to change this into shapefile. So for that, I am showing you now one very important feature to create a new shapefile. To create a new shapefile, okay? How to do that? I go to layer, create layer. Do you see it? Layer, create layer, and then new shapefile layer. Okay, so what should be the file name in this case? I can keep the file name as my big buildings, big, I can say, or important buildings, IMP BLD, that is also as 46 node. I save it as this. Then geometry type is a polygon. Then here itself I change the projection and I use a 2D coordinate reference system. Okay, and then I click OK, and I say okay, everything is fine. Now I have this important building file created and added to the left hand side of this software interface, as you see here. So this is with which I am going to create these buildings in my layer. As you know, it will have a attribute table like this. Right now there is nothing in the attribute table, so you toggle this and then you make it editable. Okay, and then you zoom, and then you use this layer add polygon feature. Okay, and then click on there and you roughly create the buildings. I am not showing you the snap option for the time being, just create it. So double click, and then ID, this is building 1, suppose. Okay, then I have 6 buildings, right? Go to the next building, this one, this one, this one, this one, building 2, this is my building 3, this one, this one, this one, this one, 3, this is my 4th building, there, this one, this one, fourth building. Then my fifth building is somewhere here. Fifth building. This one. This one. This one. Fifth, and one more building is there, right? Where is that? Maybe here. This one. This is my sixth building. This one. This one. This one. Sixth building. Okay. So after this, I can deselect these KMZ files which I have added, and then simply I can remove it from the layer. Yes. Then see, I have now the building layer, as I can show you. Right click and then open attribute table. I have 6 buildings, 1 2 3 4 5 6. Okay, and then I can add one table. I can add one field here to name these buildings. So names of buildings. So if it is a name, you are going to write it in a text. So change it to text, and you can keep the length of this text a little bit increasing, maybe 20. That would be enough. Okay. So first of all, one is building 1, BLDZ 1. 2 is building 2, BLDZ 2, BLDZ 3, BLDZ 4. Oh, our thing is going to get ended. 5, BLDZ 6. Okay, and then once it's done, you save it. In order to save it, toggle editing mode and then click save. Done. Oh, it didn't work. Wait a minute, that mess, there's something wrong with the ID. Just a moment. Okay, anyway, I think we will have to cut short this thing because it's going to get stopped anyway. So for the time being, I will stop here, and then in the next class I will show you some of the advanced geoprocessing options. So next one will be, I will be querying how many buildings are there within 1 kilometer radius of the stadium. Then again, how many buildings are there within, suppose, 1.5 kilometer radius of the assembly building. So automatically this query will be given answer by the software. Okay, so before it gets closed, I will stop here, and then before I stop, as I showed you in the last class, I want to save my project. That's why I can save it here, go there, and then it will be saving as a type of QGZ file. And where I am going to save it, I want to keep it in the same folder. Okay, just a moment. My geoprocessing buffer, suppose, file name, and then it's from Manipur. I'll save it so that next time I can simply click on there and then it will pop up. Okay, so I will anyway share you the video, and then as I have shared you the dataset, you please work with the dataset. Once you, this is a very basic thing. We are still going towards the core of GIS a little bit late, where you will be handling the raster data. Okay, you have to equally be able to do the processing for vector as well as raster. Only then you will be able to say that I am quite proficient in GIS. Okay, any questions? Otherwise I will stop here.
No, sir.
Okay, okay, good. So I'll stop here. Okay, see you by Thursday.